So today, we're going to dive into one of the most absolutely breathtaking spectacles in our sky, the celestial shadow play we call an eclipse.
You can imagine looking up, safely of course, and seeing the sun just transformed into this blazing, perfect circle of light, kind of like a celestial donut just hanging there in a dark sky. It is an absolutely unforgettable sight.
And then you've got those nights where our familiar, silvery moon just seems to blush, turning this deep, almost haunting coppery red. It's often called a blood moon, and it's mystified cultures for, well, millennia.
But that brings up a really good question, right? I mean, the moon circles our planet roughly every 29 days. So shouldn't we be getting these incredible light shows every single month? Why are they such a rare treat? Well, that is the exact mystery we are going to solve today.
Okay, let's get right into it. The very first clue to solving this puzzle is all about alignment. It's about getting these cosmic billiard balls to line up in a perfect straight row.
And science actually has an amazing word for this, syzygy. Yeah, that's S-Y-Z-Y-G-Y. It's a bit of a mouthful, I know, but all it means is that the sun, the earth, and the moon are in a nearly straight line. This is the absolute first thing you need for any kind of eclipse to happen. And this perfect lineup can happen in two basic ways. For a solar eclipse, you've got the moon smack dab in the middle, casting its shadow right on us here on Earth. For a lunar eclipse, the Earth takes that middle spot, and it's our planet's shadow that gets cast onto the moon.
Now you've got to know, not all shadows are created equal. The umbra, that's the deep, dark, central part of the shadow. If you happen to be standing in the umbra during a solar eclipse, that's when you get to see a total eclipse. And then, surrounding that dark core, you've got the penumbra. This is the fainter, kind of fuzzy outer shadow. If you're in the penumbra, you're only going to see a partial eclipse, like someone's taken a bite out of the sun or the moon.
Okay, so let's see how these shadows come together to create our first main event, the solar show. Solar eclipses really come in three main flavors. You've got your total eclipse where the sun is completely hidden. There's a partial eclipse where the moon just sort of grazes the sun. And then there's that stunning annular eclipse, the one that gives us that famous ring of fire. So what's the deal with that ring? Well, the moon's path around the Earth isn't a perfect circle. It's an ellipse. So sometimes it's a little closer and sometimes it's a little farther away. When it's at its farthest point, it just appears slightly smaller in our sky. And if an eclipse happens right then, it's not quite big enough to cover the whole sun, leaving that incredible, brilliant ring of fire.
And listen, this is probably the most important thing I'm going to say today. I really cannot stress this enough. Never, ever, ever look at a solar eclipse without proper, certified eye protection. The sun's radiation is no joke. It can and it will cause permanent eye damage, even blindness. There are no exceptions. Seriously.
All right, let's shift gears. Let's look at what happens when our own planet gets in on the action, creating the lunar eclipse and its famous eerie glow. So this brings up another one of those fascinating questions. If the Earth is completely blocking all the direct sunlight, why does the moon turn red? I mean, shouldn't it just go completely dark and, disappear?
The secret, and this is so cool, is actually our very own planet's atmosphere. The science behind that blood moon is the exact same science that paints our skies red and orange every single morning and evening.
So here's how it works, step by step. First, sunlight streams past the edges of our planet, right through the thin layer of our atmosphere. That atmosphere scatters away most of the blue light. What's left is the reddish light, which gets bent or refracted right into Earth's shadow. The moon, just sitting there in that shadow, gets completely bathed in this reddish glow and reflects it right back at us. It's incredible when you think about it. It's like the moon is being lit up by every single sunrise and sunset happening on Earth at that exact moment.
And hey, here's some great news. Unlike its solar counterpart, a lunar eclipse is totally 100% safe to look at. You're just watching moonlight after all. No special equipment needed. You can just go outside, kick back, and enjoy the show.
Okay, we've seen how eclipses work, but now it's time for the big reveal, the final and most crucial piece of the puzzle that explains why they are so darn rare.
So let's circle all the way back to our main mystery. We've got the sun, we've got the Earth, and the moon is making its lap around us every single month. Why isn't this perfect alignment, this syzygy, a monthly thing?
The entire reason, it all comes down to one small number, 5 degrees. What does that even mean? Well, it means the moon's orbit isn't perfectly flat compared to Earth's path around the sun.
It's actually tilted by a very slight but incredibly important 5 degrees.
And because of that tiny 5-degree tilt, most months the moon's shadow just passes harmlessly above or below the Earth. And the same thing happens the other way. Earth's shadow usually misses the moon completely. The paths only line up perfectly for an eclipse during these short windows of time we call eclipse seasons. That's it. That tiny tilt is the sole reason these stunning events are a rare spectacle and not just a monthly routine.
So the next time you get to see an eclipse, just remember that tiny little tilt that makes it all so special. And it leaves us with one final kind of mind-bending thought. What if there were no tilt? Just imagine a world where we had monthly solar and lunar eclipses. How would that constant, predictable dance of light and shadow have shaped our science, our cultures, and our fundamental view of the cosmos? Something to think about.